Welcome to Muse and Metrics. This is your host, Philippa Burgess. This is Season 5, Episode 16. Today's topic is Dive into Data Science.
My name is Kaitlin Bustos. I am a Google Women Techmakers Ambassador. This is my first year in the program, and I'm really excited to be a part of it among a bunch of other amazing women in tech. My role in tech, I'm a data scientist / data science contractor at the moment / data science speaker. I'm doing a bunch of data science activities at the moment, but I've worked in industries such as nonprofit and consulting. Just being a data analyst and data scientist. My primary expertise is with social science data and life science data. That's where my passion really lies when it comes to data science. And next, I've kind of dabbled in the nonprofit space and also biotech space, so the life sciences. But next, I think I really want to go into social impact and using data for humanitarian aid purposes.
That's
a little
awesome.
bit about me, yeah.
And how did you discover data science and then learn data science? What's sort of your path to get to where you are?
So it basically all started with a Google search. I minored in statistics in university, majored in psychology, so I do come from sort of a non-traditional data science background, but I absolutely adored statistics in university. Said no one ever, but I did. And once I graduated in 2020, so during COVID, and the job market at that place was kind of all over the place. So, okay, what do I do next? I always knew I wanted to further my education, but I thought I was going to go into neuroscience, even psychiatry, maybe, but I kind of wanted to explore my deep passion for statistics. So yeah, it was a Google search, what roles involve statistics? And I think I just found a blog post on data science and what a data scientist does and their role. And it really resonated with me. And probably not even a month after I figured out what data science was all about, I was enrolled in a data science diploma bootcamp. And boot camps are pretty intense. So 4 months after I had my first data analyst internship, and then another internship after that, and a contract as a subject matter expert in AI. And then I got my first full-time role in data science as a data science consultant. And I worked in that role for a year and a half. And then I decided to try out freelancing. So that's what I'm doing currently. So doing speaking engagements, mentoring aspiring data scientists. I'm working on some of my own personal projects. And then my next upcoming contract is a subject matter expert in data science. So I'll be writing or authoring with a team, of course, data science practitioner certification questions, which is really exciting.
That's awesome. I love that.
Yeah.
And I'm going to say in my spatial data science, which is different, and yet they intersect and yet they're siloed. But in my learning and things I'm seeing and people I'm hearing talk, they say statistics. You need to know statistics. If we could give anybody one piece of advice, it was be really good at statistics, embrace and love statistics. So I am hearing that. And I love that you do come from that background. Someone else sort of was saying calculus is a really good thing to know and embrace. And in my education, they were not included. In my current education, they're still not included. So I have found lots. I've been gathering. I've been in collection mode, and now I actually kind of need to transition into read, learn, process, share mode of different books and courses on statistics and calculus. And so all of that is part of my learning journey. So I love hearing that is, and you're confirming, foundational in a data science role.
It is. It's super foundational. And it's interesting to me too. I feel really lucky, I guess, that I had that statistics minor to give me that solid foundation, because even in my boot camp, I think we focused on statistics for maybe a day. And I was like, oh no, what about all these aspiring data scientists who don't have that statistical background? Because it is so important, because we can draw insights from correlations all day, but you need to, obviously do statistical tests to make sure that those insights are even, valid or statistically significant, right? And calculus is a big one too. I wish I was better at calculus, but I think that's for like the machine learning models and understanding those, which is an area that I also want to dive into as well. But with data science, it's so hard. I feel like there's so many even sub fields or sub branches that you can focus on. Like you can focus solely on data visualization if you want for your whole career, or you could go into machine learning or anything. It's a little bit overwhelming actually, but there's so much still that I want to explore when it comes to data science.
And that's how I feel. I fell in love with, I'll kind of say I came at it from data visualization. I was finishing a master. They kind of included this at the end of our program in urban planning. So last year I finished a master's of arts in urban planning. And in that last semester where I was like, what am I doing with all this? What do I go do with this master's of urban planning? Love the program, but didn't see a workable application for me. And I could see that in my courses, we had a big data course. I was the one who lit up and was super excited about the learning R Studio. And everybody else was like just eye rolling, like, oh, like we hate this. And I was like, ooh, I love this. Like, this is my jam. Like, this, I love this. And then as I was learning about GIS and data visualization, it was like, okay, I have now found my place. And that's what I, started with a GIST certificate for Geographic Information Science and Technology, which I just finished last week. And right when I started that program, I was very clear. I was like, I don't need a lot more than a year to really kind of go in the directions that I want to go. And also figuring out, where do I want to apply this? My school has a PhD program in health, population, and data.
Oh,
and so what you're saying,
that sounds awesome.
Well, there you go. It's online.
Yeah.
And that's, but I'm not as much on the health side. And actually, one of the guests I interviewed is a medical data scientist, data analyst. Yeah. And she is very much excited about working with health and medical data. And so that's its own niche. That's its own universe, really, within the data science. And I am learning about digital twins and 3D modeling and BIM, yet I understand that I need to know SQL and Python and RStudio and just kind of understanding how all these pieces fit together and just getting deeper into databases. And now that I've decided I want to be a GDE, at first I was like, well, what platform am I going to be an expert in? And then I realized I'm just going to own being an expert in geospatial. And that means that I'm proficient at understanding the Google Earth and the Google Earth Engine and Google Maps and how they're now creating this immersive experience with maps. And yet in my school, there is a major that is spatial data science, but it's only for on campus, and I'm an online student. So when I was looking at what my options are, I ended up going with a master's in human security and geospatial intelligence. So I'm looking at now applying data science more to disaster resilience, disaster response. And I think that to me kind of uses my foundation in urban planning and then just learning how to use the mapping software, and now adding another layer of understanding how we're collecting and processing satellite imagery. So like you talked about AI, machine learning, there's a whole world within that space that I'm wanting to get more technically proficient at. With all that said, though, I was at a conference this summer, and of the tens of thousands of people who were at this mapping software conference, which is Esri, it's a user conference, I realized I was probably the only person at the entire event who identified and had a longstanding career before I went back to school as a podcaster, as a blogger, as a YouTuber. And so I was like, ooh, I've been feeling like I was leaving those things behind. And I was like, this is really the opportunity for me to bring those things forward and fold them into my work to help amplify these voices and tell these stories and be someone who can inspire and encourage this learning journey. Because I feel like over the last 20 years, all of us have had to become digitally literate. And now I think all of us need to become data literate. And I think within my university, I was looking at all the classes that the university offered in all the majors. And I noticed that data science was now embedded in every single curriculum. So whether you're studying biology, psychology, communications, criminal justice, international relations, which I graduated as an undergraduate in, we didn't have data science when I graduated some 20 some years ago. So therefore, it really is the now. And whatever you do going forward, you have these foundational skills. Psychology is foundational. As I do these tech interviews, we talk about technology, but we also talk about people, relationships, community, management, leadership. And so having that foundation in psychology and understanding what motivates people and how they think, I also think actually those soft skills really do integrate really well for women in tech.
Oh, of course they do. And even I've noticed that I think even the most with just like stakeholder management skills too, because communication is such a huge part of data science, right? And I feel like if you're just behind a computer screen coding all day, you don't really get to exercise the people skills that you mentioned. And I think communication like could easily be one of the most important parts of data science too, because you could have the best script like or algorithm living on your computer, but if you're not even able to get like stakeholder buy-in for that, nothing will technically ever come out of it, right? So yeah, I think communication is so key, and psychology definitely gives a solid foundation for that in data science. And I've noticed it too. I was in a technical interview recently, and they asked me a question about how I thought my psychology background, helped me as a data scientist. And aside from the stakeholder communication bit, I feel like it just gives a different perspective to a data science team. Like, so at least in my experience, the data scientists I've worked with have mostly come from like a computer science background, engineering background. So like they've seldom taken or took psychology classes or anything like that. And it's obvious in the way that you kind of tackle and approach different problems. Like, for example, I remember me and my coworkers were doing just a code review, and there was a bug and we didn't know. And like the kind of the hardcore like engineering background data scientists were like, we're kind of jumping to the most like technical conclusions and like very complex things. But I feel like with my background, I was able to kind of even just look at that script and be like, actually, I think we're just calling the data file wrong. Like it was just a simple typo, right? So I feel like that it's such an interesting difference on how individuals' backgrounds like necessarily, contribute to a team. And I think it's so important too. And I think that's like I always encourage people from like non-traditional kind of tech backgrounds to try it, to come into tech, because I think that diversity in a team is so incredibly important, especially because all the technology these days too, like it's not just the engineers or anyone using it, like it's everyone, right? So having people from all different backgrounds contributing to one software that will impact everyone, I think is so important.
And that has a lot to do with user experience and accessibility. I was talking to one of our guests was talking about being neurodivergent. I identify as being neurodivergent more in the ADHD creative way that and having many people say, you think differently than other people. But for hers, it was more of a light sensitivity and sound and not, when she's looking at developing software, she's thinking, is it accessible for someone who's colorblind?
Exactly.
And if you don't have a diverse team, you might not think of those things.
Yeah, no, completely. And yeah, and it's stuff that I think sometimes can even slip individuals' minds. Like I was giving a workshop on data visualization at UBC, and I was basically demoing this dashboard that was just like a mock dashboard that you hypothetically could use in like a clinical setting or something, because these were pharmacology graduate students. So I tried to tailor the workshop to kind of data that they would understand, so like pharmacokinetics and stuff like that. But it was interesting how I really had to kind of explain like why the layout was the way it was. Like, for example, the dosage of medication in the dashboard was like big, bold at the top, like first thing you see. And they're like, well, why? Because like, I feel like they're just used to, you know, making a very like rudimentary like plot in ggplot2 and R or something with like a legend, like maybe not that aesthetically pleasing, but like when you take a visualization and kind of try and apply it to industry, it's so important. So like, why was the dosage so big and bold at the top? Because, well, if a clinician was to see that and like, or check up on their patient, or like it's a patient dashboard, that's probably what they're most interested in. If it's like just a dashboard on the medication they're taking, like that's a very important piece of it, right? And so it's like, it would make no sense to have that dosage in a little box in like the corner or something. And it was so interesting to just see the audience's face like light up and be like, oh, that actually makes so much sense, right? And even like colorblind friendly like palettes and stuff that you can use in R and stuff, I think are so helpful. And it's cool that like data science is definitely, as you mentioned earlier, it's the new thing now. And I think there's so many little like nuances that we need to remember, since it is the new thing now, and like data is everywhere and we're using it so much. So.
And when you talk about the visualization, I took as part of this gist, one of the first two classes we had, again, we're on the spatial side of it. One was spatial thinking, the other one was spatial data acquisition. And then I moved over to finish those and had cartography and visualization, and then just finished with an SQL class. And that's kind of a part of that gist. And then I'll continue on the fall with Python customization. And in the SQL class, it was a mix of students coming in from all sorts of different backgrounds. I don't think any of them were part of the cartography class that I had just taken.
Yeah.
And yet we were using ArcGIS Pro, which is one of those mapping softwares. And there was detailed instructions of how to build your map for one of our assignments where we were looking for topographical errors. And I went through all my classmates and I realized that not all of them understood sort of foundational things, like if you're going to have water, make it blue. And if you're going to have an ocean and a lake, distinguish them, like give them different blues. And it was just details that I had picked up in the cartography class. Maybe I might have not really put that same thought process into it, but having come through that class, I was like, oh, okay. And I really saw that I was really proud of my map. There wasn't an opportunity to give feedback to my classmates, but just kind of looking at my map versus the other ones, I was like, the fact that for me, those were really hard-won skills to actually have a map that I was super proud of. I was like, oh, I've learned a few things in the last year I've been in this program, because again, I think a lot of the students who came into this class, many of them, this was like the first time they were touching the ArcGIS Pro software. And after a year, I still feel like, ooh, I'm at the beginning. it's a massive world. And also because of my interest in being a GDE, I spent 2 days at their conference running around going, okay, where do Esri and Google connect? And they really don't, except for databases, because databases is the foundation of where you're organizing and pulling the data. So I figured, I was like, okay, I'm going to go deeper into databases. But even a lot of the logic there, I get it, but I'm slow at getting it. So it kind of bends my brain. So in databases with or SQL, we were looking at the diagrams. So you're sort of diagramming what connects where, what kind of data you need. The entity relationship diagrams, the ER diagram. And then from there, how you simplify it to 1NF, 2NF, 3NF. And I understand that conceptually, but to apply it, I realize I need a lot more practice.
Practice is key for sure. It's interesting the way that so did you learn R first? Like, was that your first kind of programming language, coding language? In
my urban planning is where we were introduced to R. But so back in my day, let me give some context to age and generation. I am fully analog and I'm fully digital. I started college in 1992 and I was coding HTML because it was brand new to me. And I was like, ooh, I could build a website, and like this predates Google. So whoa. I've always been very technically oriented and technically inclined. I've always been an early adopter to technology. And so I think that now owning my identity as a woman in tech, a woman in STEM, I don't think I would have really done that if I hadn't gone back and got their certificate, or now that I'm in a Master's of Science program. I'm really sort of, because I always felt also as someone who had gone a creative path, excluded. Once I'd kind of chosen that, there wasn't really, I never felt anybody in maths or sciences said, oh, come over here. And yet also I never felt that I was encouraged with math or science in an academic setting. My parents set me a really solid foundation in math, and I'm grateful for it. And so I feel like now that I'm revisiting statistics and calculus and linear algebra, it'll all come back and I can get it pretty quickly. So yeah, R was my first. And then started with Python, and it was an epic fail because I had so much trouble figuring out the interpreter. So I understood conceptually everything they were introducing, but I couldn't actually apply any of the exercises because, so finally, when I did the intro to machine learning that the Google group brought us, they said, go use Colab. And so I decided that I'm like, let me just start with Colab. I'll see what they introduced me to in my fall semester. But I downloaded PyCharm, I downloaded Jupyter Notebooks, but I Visual Code Studio, but it was just kind of overwhelming to me. And what do you recommend? What do you like to use? What tools?
Yeah, so that was just so interesting to me how I think people applied or even approach problems even differently just based on the order in which they learn different technologies, which is crazy because I guess I learned R first in university, but to be completely honest, like I don't even know how I was able to like scrape by that, because looking back, I was like, I had no clue what I was coding, no clue what I was doing, like right over my head. But when I went into my data science diploma, we learned SQL first. And that, so it's interesting because SQL was my first kind of like real, I'm not going to count R in university because I feel like I don't know, Stack Overflow maybe. But yeah, so SQL first, and then it's interesting because everything that I've done now, I feel like I build on SQL. So like, learning how to like join different tables. Like I feel like SQL made me very much more data literate. So I learned SQL first, and then we jumped into Python. Or actually it might've been like SQL and then Tableau. So kind of sticking with like more of the low code, not like so much hardcore programming. And then we did Python, and then kind of worked our way up from like using pandas in Python just for, EDA, and then looking at like stats models and then all the way up to machine learning. So that was one thing that I really appreciated about my data science diploma program, like the way in which they built up our skills. It was so seamless, it seemed. And I think it helped aid some of that like confusion that you're talking about. And then in my first real like full-time industry role as a data science consultant, I had moved back to R because that's what that was what the language that we coded in for our biotech client. And then it was so weird. Like, I feel like I picked up R so much more, like I actually understood for once what I was doing in R after, the SQL, Python. I was like, wow, I really wish I had a better grasp on this in university, because I think it would have been so much more fun. But yeah, currently I'm a really big R lover. I'm trying to code a little bit more in Python, just to keep my skills sharp there. But
what interpreter do you use?
So I use the RStudio IDE, and then I just use VS Code, and then in VS Code I use Jupyter Notebooks.
Okay. Yeah. See, that's the piece on the back end I've got to like figure out. That's why I'm like, I'm just going to go with Colab right now because it seems like it's so simple, but I'm sure it's lacking some of the more other things that are useful as you go. And I think once I get into real world application, it will all reveal itself much better. And also just trusting that I'm in a program that will help with that learning transformation. So I'm really looking forward to my Python class this fall.
Yeah, exactly. That'll be good. I know. I feel like I am also sort of missing some of those like technical bridges. That's why I want to take like a foundational level like computer science class as well, I think that would help me a lot as a data scientist, because yeah, so we used Jupyter Lab and Jupyter Notebooks, right? But then when people talk about Python and like compiling code and just pure Python scripts, like I'm not even really sure how that all works, right? So, but honestly, it's good to know for sure. But I think it's also amazing that we do have tools like Google Colab, and what's it, Notable is another one, and then like Jupyter Notebooks and stuff. And it just makes it easier, for sure.
And that's what I want to kind of go back to, because I had done, actually, it was a Google course. It was actually, I think I found it right before I became a Women Techmaker ambassador, and I think I started using it right when just at the beginning, because I became an ambassador last fall. And I went through the 5-hour videos, and they had all these exercises. I just couldn't execute because I was struggling with my interpreter. So now I kind of actually want to go back and revisit that class. And what I liked about it is that everything about strings and tuples and all those things, once you learn foundational language, it translates across. There's just a whole set of language that once you have it, it doesn't really matter whether you're in Python or R. Mm-hmm. It's all the same concepts.
Exactly. It's exactly the same. Like there's so much overlap, which is cool. It's still confusing to like switch back and forth with the syntax, but no, yeah, the basic concepts are the same. Like the pandas, functions are pretty much very similar to the tidyverse functions, right? So yeah, that makes it really great too.
Now, do you do mapping? Do you do chloropleth maps and that sort of heat map?
No, not usually. Like the only heat map that really even comes to my mind right now is just like a correlation heat map. I go to those a lot, but that's about it for heat map.
So we used with R, we used a program called Geoda, Geoda, and it was very lightweight, but you could pull in any of your R data sets and just put it on a map. Oh. And it was a very simple tool, and it was what we used to sort of be able to ask and answer questions that had a spatial component to them.
Very cool. There's so many great packages out there that I need to check out.
Yeah, I think Geoda is sort of its own software, but it's free, and it's very lightweight relative to ArcGIS Pro or anything in the Esri suite of software solutions. So Geoda was sort of a free download that was if you were looking to create any kind of heat map or that kind of map visualization. It was quite good. And it also did other linear regressions and other things too, and just another sort of visualization tool that we were introduced to that I liked as a primer. It was quite good. Now I'm in ArcGIS, which is it's quite overwhelming, and I think that the issue with spatial is you're just dealing with a bumpy ellipsoid that is the Earth, and all of these different coordinate systems and projections, and that's where are you dealing with geometry or geography? And then there's the raster data is what is like a layer is a sheet, and then vector data is your points, lines, and polygons. Yeah. And so we have kind of all of those things in the spatial, but I still feel like we need to layer all of this on the traditional data science foundation.
Yeah, no, for sure. That makes sense. It reminds me, I guess I have worked with spatially resolved like single cell tissues, and all these, you mentioned coordinate data, and I just remember having to reorientate a mouse brain, and it was just a bunch of different single cell coordinates, and it took me back. I was like, how am I going to do this? But simple trigonometry worked out for me. So
I recently had surgery, and they were doing they didn't cut me open, but they stuck a camera down, and then they did whatever they needed to do, and it felt like it was a spatial data science exploration, because essentially my body is a place that can be mapped. And so it'll be interesting to see how, like you said, you're working with a mouse brain, how we can also be using these technologies in medicine, and how we can start to have coordinates on the body.
Hmm. That's so interesting. Yeah.
It's growing very, very quickly. There's no question
Super
about that.
rapidly. Hmm. Yeah, in every industry too, I think it's just because it makes sense. Like data is everywhere in every industry. So, and yeah, in every industry in data science, I think you mentioned this earlier, is its complete own little world. Like I was just in a data science hangout, and there was an individual, I think he was like the director of data and analytics at the NFL, and just hearing him speak about sports analytics and the stuff that they're using to analyze like player data and game data, it was just so mind blowing. Like it is a whole completely different world, and I wonder if spatial data is something in there. I think it is. I have a friend who's actually in the CFL, and he says that they have like a vest and they wear like trackers on it to collect data and stuff, which is so cool.
In the spring, I have a class on remote sensing, so I'm not even
Mm.
clear about all the details of what actually is remote sensing. But it's just basically, in its simplest form, it's you're not there. There's just the sensor is remote. It's wherever, and then it's just gathering data, and then it's feeding it to you, and then you can do stuff with it. Part of my degree is geospatial intelligence, and the fact that sometimes we think of space as the infinite universe and galaxies, but really what this is that we also have all these satellites flying around us at all times, just capturing every place on the planet. It used to be that was every 16 days, and then it was every few days. Now it's every 24 hours. We capture every inch of our planet in imagery.
Mm-hmm. That's so much data.
That's a ton of data. But you're able to see before and after, and then you layer in the machine learning part of it.
Mm-hmm.
And for those who aren't as familiar with machine learning, I'm just going to sort of say what I'm understanding is that the uses of machine learning in at least spatial data, and I'd love to get your thoughts on how it's used in the data science, is it's used for categorization. So it can look at images and decide what is what once you train that model. And then it's also used for change analysis. So it can identify where there has been a change. And then I think going forward, as these models get better, it can then make predictions.
Yeah.
So those are kind of what I see on the spatial side. So I'd love to get your thoughts on the applications of AI and machine learning, and machine learning being a subsection of AI in data science.
Yeah, I feel like it all depends, I mean, on the context of the problem, right? Is when you're gonna use a machine learning model, which one you're gonna use. It depends on like the nature of the data as well, because we have supervised machine learning models in which you know what you're trying to predict, and then you can train the model, versus unsupervised models where you don't really know what you're looking for, and so like k-means clustering, for example, and just looking for different centroids and pulling the closest other data points in. It's so interesting, yeah, and it just depends on your use case, I guess. One a machine learning model that I always go back to is logistic regression. Well, technically it's a statistical model, but it's still making predictions, so it is a machine learning model. But yeah, I used that this was my first data science project ever, like my first end-to-end data science project. It was my capstone for my data science diploma. But what I was able to do with that model is predict whether or not a psychiatric medication would be effective for an individual who was suffering from a mental illness. And it's so interesting, and you can use so many different classification models. So logistic regression, I always go back to it just because it's easily explainable, which I think is always helpful. But yeah, within that same project, I also trained like decision trees, which is another classification model, and then it built on top of that is random forest. So you can just get more and more complex with these different algorithms. But the thing that's quite interesting to me is typically the performance doesn't vary that much. So when that is the case, I always tend to go for the more simpler models, for sure. And another application that I did with an unsupervised machine learning model is, I was like, let's get individuals. I always work with mental health data just as like personal interest, but like, let's get individuals who were diagnosed with different mental illnesses, but let's not train it on the mental illness that they got diagnosed. Like, let's just train this unsupervised kind of classification model on their symptoms that they're experiencing. And it was really interesting to see how different patients clustered based on their symptoms, and sometimes it wasn't necessarily matching up with. So it's like, so for example, like an individual who was diagnosed with depression and anxiety, like the machine learning model wasn't necessarily able to distinguish that just based on their symptomatology, which is super interesting. And it goes back to, I guess, just the way that we even diagnose and classify mental illnesses is, like, maybe it's not so much of, so right now we use the DSM-5, which is kind of just like a checklist of different symptoms based on how long you're experiencing these symptoms for. But there's another approach, which is basically called high top dimensions, and it's more of a spectrum of symptoms like that. And it was so cool to see how that translated when I with a real data set, doing that unsupervised learning model. I was like, okay, so this is why high top dimensions was even, like proposed, because there's so much overlap in the symptoms, right? And that's a really exciting part to me about data science, is just how much, we're figuring out more about the world, right? And just phenomena at large. I think it's so interesting, and it can be so impactful too if we do the right things with the insights that we derive. And I feel like community is definitely by far one of my favorite parts of data science. Like, as you said, there's so many resources, there's so many people that are willing to help. And I think community, I think, is honestly what's really kept me in this industry for sure too, because I've definitely had feelings of like, okay, do I want to go back to psychology? Like, do I even you always have those feelings of, am I going in the right direction? But honestly, it's the community, the data science community and just women in tech community as well, that I've cultivated, that I'm like, okay, I actually do feel like I'm in the right place, and I feel so much support. And I think that is so important, especially in an industry like this, because it's super daunting. Like, even just hearing data science or artificial intelligence, like to someone who isn't familiar with those concepts, like it kind of sounds a little bit like intense, right? So I love to do that too in my community, just encourage people that, you can learn anything you want to learn, right? And especially if it is our future and AI is going to be so tightly integrated into everything, it's so important that we do learn, right? And yeah, community, I think, is one of the best places to learn. People ask me all the time, like, how do I even start in data science? And I think my simplest answer is just, I always say, go look at a data science bootcamp curriculum, because they will lay it out for you so perfectly. Like, I'm not saying go spend $15K and enroll yourself in this bootcamp, but even just looking at the curriculum, you'll have a very solid grasp of what you need to learn and how to build your skills to become a data scientist, right? But there's also so many free resources as well, like you mentioned, and YouTube videos and different communities, and it's very inspiring to see as well. Like, it definitely pushes me forward to inspire others as well, when I see a bunch of other women in tech, or just other individuals in tech in general, kind of advocating for data science and AI, and especially using it for good too, and just advocating for the power that it holds and how it can help all of us.
And I think that, to go back to the statistics and how it helps us, is they gave us an example at one of the conferences I was at, and this was the guy who's like, I need you all like learn statistics. This is so foundational to this industry.
Yeah.
I just need you all to, and he gave us an example of a statistics class where the professor put the students into two groups. And in one of the groups, they had a real coin. And in the other group, they had an imaginary coin. And they were both instructed to flip the coin 100 times and mark their results on the board. And then he left the room. And when he came back, he could always tell who had the real coin and who had the imaginary coin. Because the way that our brains process information, and you would know this coming from a psychology background, is we actually think fairness. We think that the world has a certain fair. So the group that had to flip a coin would only allow it to go a certain number of times heads before they're like, oh, it's time for us to go tails, because they were making it up.
Yeah.
And the ones that had the real coin, reality, will go tails, 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 oh, heads. Yet the group that had the fictional one, and they had to like make up and agree as a group, what's it going to be next, would only let it go so many times before they had to flip it again, because they had this idea of fairness in their head. And so statistics show and data show us the truth, because a lot of times we make up stories in our head. And then, of course, the way that the algorithms work in terms of how they feed us the news now, we all get the news that just forms around our already beliefs, and it makes us believe more, and we're not actually looking at a set of facts. And so data science to me is so important in terms of now we're all looking at the same data. Now we can actually start making policy, start making decisions, start implementing plans based on this actual reality. But then, of course, you can go take it other levels where sometimes this reality is not reality, and we have to question and understand and communicate as data science, how accurate was this information? How clean was this data? What were the limiting factors about how this data was collected? And be responsible for communicating that this might not be the end all and be all. I've definitely seen politicians in Congress show a graph and say, oh, look, it was this. And then this politician came in and now it's this. And I was like, where's the data set? Can you please direct me to your data set that created that graph? Because this just seems like hyperbole and just really convenient. And there's no underlying, I wished he would have said, oh, and this is where this data came from.
Yeah,
exactly.
Yeah, I love how you said that, you know, there is another level that, yeah, we are all seeing some ground truth of data at one point, but then after that, we need to also be able to critically think and know that, okay, though we are seeing this ground truth data, we need to critically think about it, and it's not the end all be all, right? That was something I usually mention in my mental health and data science talks. I'm like, disclaimer, I'm not saying that data science is going to cure mental illnesses at all, but at the very least, you know, it can help, you know, us determine some sort of certainty from a lot of uncertainty, which is kind of the field of psychology right now. It's super gray, right? So yeah, critically thinking is such an important aspect of data science.
And I think you get that critical thinking from intersectional thinking, intersectional by generation, intersectional by gender, intersectional by culture, intersectional by other fields of study. And so, for example, I now have this urban planning background that we had a question that was brought to us in our SQL class, I think was one of our discussions. And they talked about a group of researchers who took Google images and they were looking at just the two factors, cars driven and voting record. And their conclusion was basically based on looking at Google images. If people were driving pickup trucks, they were saying, hey, that's Republican. And if they were driving sedans, they were saying, hey, that's Democratic. And I actually looked at that and I said, you know, I would really have liked to see that study take in a third factor, which is population density. Because I drive a pickup. I'm kind of liberal. But why do I drive a pickup? Because I live in a rural environment. I bought a pickup when I lived in Colorado, and then I drove that pickup to rural Pennsylvania. I drove a sedan when I lived in LA, and when I'm with my mom, I'm in a sedan. And so I think that I'd like to have seen that study also based on population density. And I think that then you would actually see that there's even a bigger correlation between how people vote and population density.
Yeah, for sure.
And so I thought it was
yeah.
interesting that they started, but then I was like, there's more to this. You could sort of pull it out in other ways.
Exactly. There's so much more to, I feel like most data sets, right? It's like, okay, what is truly the context behind all of this? Or even like a single data point, right? Because you could see you know, a row of data, let's say it was associated to a patient, and you could completely draw conclusions about that patient, but it's like maybe that day they were having a really bad day. So like, is that really representative of, you know, like the type of patient they are, or this or that? Like this is especially relevant when it comes to like survey data, right? I think I took a statistics course. It was like sampling methods, something we focused a lot on survey data, and you know, all the potential biases that, you know, can creep in when collecting data, in all the way from how a question is phrased, to the options of the question, to who is asking the question, to what time of day the survey was taken on, like to the volunteer sign up sheet. Like there's so many moving pieces, which sometimes we can't capture absolutely everything. So yeah, it's so important to always have that kind of like take it with a grain of salt in the back of your head too, because there's so much that we still don't know, even if we do have a really great comprehensive data set of some sort.
Another data point that we look at in urban planning and spatial data is tree cover. And they've looked and seen that tree cover is one of the things that distinguishes an affluent neighborhood from a not affluent neighborhood is tree cover, because tree cover, it provides shade, it cleans the air. If I was doing some mapping data with all old red line maps in New York. So in the 1930s, they created these maps of sort of, you know, what's a green area of like good, or a red area that they wouldn't underwrite mortgages for. But the thing is that if you look at you overlay that to today's map, you will see that all the green areas have a lot of access to playgrounds, parks, open space. All those red areas still today have no parks, no open space. And owners will plant trees. Resident-owned owners will plant trees. Right. Renters, their owners don't plant trees. So in the master plan now of Denver, they're saying, okay, we're acknowledging inequities. We're acknowledging that we have broken neighborhoods and sidewalks that don't connect, that don't make for a good walking experience or a good bike riding experience, that lack tree cover. So we as the city are going to start making these investments, which on the whole sounds good, except for the fact that the people who actually live there, coming back to psychology and basic economics, are not trustful of the government to begin with. And then are freaked out because they're like, oh, great, now you're just going to outprice us from our communities and tear out these social fabrics that we have, because we'll no longer be able to afford to live here because now you want to make it nice.
Exactly. I think you need to, that's such an important point that you bring up, is like, we need to really, like when we are even thinking of data science solutions, I think it's so important to like, who is this for, and like, how do they feel? And that's where like, you know, focus groups, I think, are so important when it comes to any new kind of data science project or initiative. Because as you said, like this kind of ties into like policy evaluation and stuff too. Like, are these interventions even going to be effective? Like, God forbid, are they going to, you know, like make things worse? And it's something that I think as data scientists or any kind of tech professional working on something new, it's so important to keep the end user, I guess, in mind, or whoever's receiving whatever.
One of our urban planning classes was stakeholder engagement. And then it was sort of followed by a capstone that focused on wicked problems. And there are wicked problems that just are unsolvable, but you still have to take into account, who are the stakeholders involved in these problems, and then how can you just sort of chip at them to try to make them incrementally better. And in this, we were looking at different stakeholder engagement plans. And our job was to take one and evaluate it and say, how did they do? And I actually picked one that I actually scored the best marks that I'd seen. I was like, this is what a excellent stakeholder engagement plan looks like. I was looking at ports. I was looking at Port of Long Beach, Port of LA, Port of New York, New Jersey. And the New York, New Jersey Port Authority did a 3-year stakeholder engagement with all of the people who are impacted and are part of their ecosystem. And they had all of these listening sessions and workshops and kept evolving their plan and then would represent it and then take feedback. And they had over 500 meetings and different workshops. And really, the plan is excellent. The process to how they achieve their plan was really the best I'd ever seen. And now how they implement it going forward and actually take it from idea to actual execution, we shall see, because it's a plan for 2050. But in terms of that process, you get these meetings where people are not listening, they're just talking at each other. And a lot of it is about hearing an idea or a concern, sharing information with the other party of like, well, here's our limitations, or we can take that into consideration and we can kind of both evolve our thinking and come to a new conclusion. And I think good data science allows us to do that.
For sure. Exactly. Good data science, I feel like it requires so much cross collaboration between teams, different stakeholders, everything. And I think that's what really it takes to even make a good data science project. Because otherwise you could spend all these resources. You could be even like the best coder in the world or best data scientist ever, but like if you don't talk to anyone, if you don't get out there and see if what you're doing is going to make a difference, then it might not, right? And then you're wasting lots of time.
You've chosen to do some freelance work and contract work as opposed to sort of going into a full-time position. What kind of inspired that path or that choice?
I think just being so early in my career, I think I just wanted to explore my options. And, I was doing data science mentoring while I had my full-time job. And so I kind of had got the feel of what freelancing work was like. And I was like, I could see myself doing this for at least a little bit, especially because being in consulting, you're just always working on different projects and stuff. And sometimes you don't get to take full ownership of your work. And I think that's something that I realized I really valued. So making the decision to kind of leave consulting and without really a next plan in mind, just knowing that, okay, I'm going to do what I can with my skills now and kind of help out any project that needs, data science expertise while I figure it out. Because I think, as I mentioned in the very beginning of this interview, I think my real passion, and even it's probably clear as we listen to this, but it's in psychology, it's in mental health, it is in, social impact and humanitarian aid. And I think I wanted to, without being tied down necessarily to a full-time job, kind of have that freedom to still, make an impact doing freelancing and contracts while I, make tangible next steps to the goal that I really want to achieve when it comes to data science.
And what you're saying about that passion for psychology, I feel like that's what the lessons I'm getting in my life is that we never aren't who we are. And it was a Steve Martin quote, the actor Steve Martin basically saying in his book, Born Standing Up, was that you will never leave behind anything you've ever learned. You'll always find a way to use it and apply it. And he would do his interviews, and he had one of his first jobs in high school was working at a magic shop. And if you look at his career, he oftentimes pulled out these little magic tricks and hat tricks. And that was just because that was part of that toolbox, that skill set that he had started gathering from the time he was 14 with his first job at the magic store.
Yeah, exactly. And that reminds me of myself too. Like I remember being so intrigued by psychology from a very, very young age. Like literally on my little iPod Touch, like looking up OMG psychology facts. And I was like 12 or something. So yeah, I'm always drawn back to psychology. So I knew that like career wise, I needed to kind of take a step back and figure out how I'm going to tie in, you know, psychology and data science, or at the very minimum, if it's not like full on psychology and data science, at least it's, you know, kind of social well-being and data science. So whether that be, you know, working for nonprofits or even like a little bit of what I'm doing now, I think is super helpful. And in a weird way, it kind of ties into that, just, you know, being an advocate for women in STEM as well. Like I'm not making some, you know, big solution when it comes to data science and psychology, but at the very least, I hope that, you know, I'm inspiring others. And I think so that ties in my kind of drive to help others, and which stems from psychology, right? And just kind of doing that in any way I can right now too.
I think we see very much that by being who we are, we give other people permission to be those things. Like when I met my first person who's a fellow Techmaker ambassador in a hall at one of the GDG International Women's Day events, and she said, "I'm a GDE." And I was like, "Ooh, what's that?" And now, but seeing her be a GDE, it encouraged me to say, "Oh, I'd like to learn more about that." And then put myself on the path now to be a GDE. I don't think I would have even conceived of that as a possibility if I hadn't met someone who stood as that role model, who stood as that point of, oh, if you can do it, I can do it too. I'm not saying you don't have to work hard, you don't have to go through a process, you don't have to find your own way and build your own community, but you also just having that idea that something is possible, because it was like, we'll never work towards something we don't believe can be true.
Exactly. I know. And I feel the same way too, like just being such a young woman in tech who also like doesn't have a master's or PhD and was able to come from a psychology background and become a data scientist in 2 years. I feel like, or I get messages all the time being like, how did you do it? Like, I'm a psych major. Do you think I can go into data science? And it's like, I love almost being that like source of inspiration for other people to explore even things that they're a little bit curious about. It's such a good feeling, and I'm glad that happened for you as well. And I can think 3 years ago, or let's say like 4 years ago when I graduated university, like we did not have a data science program, and that was like literally 3-4 years ago. That wasn't that long ago. But now, like you said, like data science programs are basically baked into every university at this point. So yeah, things change incredibly fast. And there's a psychiatric epidemiology master's program that's currently in the UK, and I feel like I'm just waiting for it to like make its way to, you know, US or Canada.
The industry is only going to continue to embrace this and lead universities in terms of the future workforce that they need, because health data is foundational, really. It's exciting, and you're in a great place, and you have an ideal background for where you're at and where you're going, and it'll be really exciting to see where you go next. I appreciate your time here. Just lastly, can you just talk a little, just parting words, anything else you want to sort of wrap up, and just, you know, other things that relate to your role as a Google Women Techmakers ambassador, sort of some of your plans and projects for the new year. I know there's a bunch of questions there. Pick whatever you want, just kind of run with it.
Okay. Yeah, so this is like my first kind of engagement as a Google Women Techmakers ambassador. So that's very, very exciting. And I think next in this role, I think I'm going to try and facilitate an I'm Remarkable workshop. I don't know if you've ever heard of those. So it's almost impossible to get the training slots. Like you have to be right on the dot, like 2 weeks before the session. I keep missing it, but I'll get it soon. And then, yeah, I'm really hoping to do primarily more speaking engagements, and just advocate for women in tech, advocate for the power of data science, and hopefully just inspire others to explore this industry if it's something that they're interested in, and, you know, not be daunted by it. And hopefully, you know, my voice and all of the other Google Women Techmaker ambassadors' voices, can be a big catalyst for the success of women in STEM.